Good evening. Am I audible?
Yes, sir.
Okay, let us start the today's session. What did we study in the previous class? We have understood about the initial value and final value theorem, problems on the same, then Z transform of delta functions. Delta n is equal to 1 for delta n minus n naught z to the power minus n naught. Delta n plus n naught, we have z to the power plus n naught. Okay, so these are the points we have studied. Apart from that, z transform of u of n, we have calculated, and now we'll move on to the next part, that is z transform of u of minus n minus 1. So here this is the negative time unit step sequence given by x of n is equal to minus u minus n minus 1. So for this we need to find out the x of z. Okay, so let us go with the notepad now. Is this screen visible to all? Let me know. Okay, thank you. So this is the sixth problem, and given x of n is equal to u of minus n minus 1. Okay, we need to find out x of z. Now we already know that x of z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. So what is this u of n minus u of minus n minus 1? We know u of n is this one. We know that u of n is equal to 1 for n greater than or equal to 0. This is right-sided sequence. This is called as left-sided sequence because if you take u of minus n, you will have to consider 0. Correct? You have to consider 0, but 0 is there in this sequence. That's why we take minus n minus 1. One sample less we have to consider. That's why it is u of minus n minus 1. This is left-sided sequence or negative time sequence. Okay, so let us substitute this. N is equal to minus infinity to plus infinity u of minus n minus 1 z power minus n. So what it does to the signal x of n, it changes the limit of summation. Minus infinity ಇಂದ plus infinity ಇದೆ, ಈ summation ಏನಾಗುತ್ತೆ minus infinity ಇಂದ minus 1 ವರೆಗೂ ಬರುತ್ತೆ because 0th sample we are removing, so minus 1 here. we don't have anything here. From here onwards this signal exists, -1 0 -2 up to -infinity. So -infinity ಇಂದ -1 ವರೆಗೂ ಈ ಸಿಗ್ನಲ್ ಎಕ್ಸಿಸ್ಟೆನ್ಸ್ ಇದೆ and its value is 1. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, n is equal to -infinity to -1 1 into z to the power -n. This is what we are going to write by replacing u of -n -1. So it changes our limits. Okay. Now for this one we have already calculated a standard equation. Standard equation is whenever we encounter n is equal to -infinity to +1 then we can write it as, say, first we'll change the limits. Let m is equal to -n. M is equal to -n. Then what will happen? When n is equal to -infinity, m is equal to +infinity. If n is equal to -1, m is equal to +1. Okay, this implies that x of z is equal to m is equal to infinity to 1 z power m. -n I have to replace with +m. So it will be z power m. Okay. For this one we have the equation as 1 minus summation. Sorry, let me rewrite this limits as m is equal to 1 to infinity. Whether you do summation from infinity to 1 or 1 to infinity, it is same. That's why I can interchange the limits. Okay, and directly write summation m is equal to 1 to infinity z power m. Now this can be written as 1 minus m is equal to 0 to infinity z power m. Okay, because one thing I forgot to mention here, sorry for that, this should be minus. Okay, given sequence we need to consider the given sequence as minus. Okay, it is not like I am considering, actually it is given only. I forgot to mention this minus. So let us write this outside. Okay, so it will not change the output as of now. Now I am writing this one as 1 minus this limit. You can check here, I have changed it to 0. So to make it 0, 1 minus summation I have taken. So what is the meaning of this actually? Summation of m is equal to 0 to infinity. What is this? This is nothing but substitute m is equal to 0, 1, 2, 3 up to infinity. That is z power 0 plus z power 1 plus z power 2, like that. Okay, so z power 0 is 1 only, correct? That's why we can write this as, this equation is nothing but z power 0, that is m equal to 0 plus summation m is equal to 1 to infinity z power n, correct? So z power m. This one I am writing in this way, m of 0. So 1 is z to the power 0 is 1, and this 1 and 1 will cancel out, correct? This is brackets minus, right? So because of that it will be minus, this will also be minus. So -1 and +1 will cancel out, you will get the same result. So we are manipulating in this way. Okay, so you can simply remember that whenever we come across this term, we can replace it by 1 minus m is equal to 1 to infinity. This term we can replace it by m is equal to 0 to infinity, 1 minus, okay, z to the power m. So already we know the standard equation for this. N is equal to 0 to infinity, a power n is equal to 1 divided by 1 minus a, provided magnitude of a is less than 1. So this is the relation what we know. So using this we can write 1 minus 1 divided by 1 minus z. Okay, now simplifying this we will get 1 minus z minus 1 divided by 1 minus z. So this is minus z divided by 1 minus z. Okay, this is the answer we are going to get. So to make this minus, that is to take out this minus from the equation, we can consider minus 1 as common, so it will become z divided by minus 1. If I take, it will become z minus 1. Okay, so minus 1 and minus 1 will cancel out, you will get z divided by z minus 1. But according to this rule, magnitude of a is less than 1, so magnitude of z is less than 1 is our ROC from this equation. Okay, so let us write combining both the things. For an x of n is equal to minus u of minus n minus 1 will give us the z transform as z divided by z minus 1 with ROC z less than 1, and it should be plotted as say this is a pole at z is equal to 1. You can understand here, if you substitute z is equal to 1, 1 minus 1 is 0. So at z is equal to 1, 1 divided by 0 is infinity. So this is a pole. Z is equal to 1 andre 1 pole. So we can write it like this, and we have to draw a circle. This is the only pole we have. And what is 0? If I substitute z is equal to 0, x of z, 0 divided by 0 minus 1. So answer will be 0, x of z will be 0. So there is a 0 here, and this is the pole. And according to ROC, whatever we have got, magnitude of z is less than 1. That means this is the ROC. So it can include 0, but it cannot include the pole. Okay, so this is how we are going to write ROC of the Z transform which we have calculated. Okay, is there any doubt regarding this problem? Yes. Any doubt? Let us move on to the next one. This is a very important problem. Sin omega naught n multiplied by u of n. So problem is x of n is equal to sine omega naught n u of n. Is this a right-sided sequence or left-sided or a double-sided sequence? Yes, it is a right-sided sequence because we are multiplying sine omega naught n by u of n. So limits automatically will be from n is equal to 0 to infinity. Remember this. Now let us move on to the procedure what we know. X of z is equal to x of n z power minus n. So now what is x of n? Sine omega naught n u of n, sine omega naught n u of n. Here let me write n minus infinity plus infinity sine omega naught n u of n z power minus n. So how we can rewrite? U of n is multiplied, that's why the limits will change. So we'll change the limit as n is equal to 0 to infinity. ಇವಾಗ ಏನಿದೆ sin omega naught n multiplied by z to the power minus n. Only these terms are left. Okay. Now it is the Euler's equation which we are going to use. What is Euler's equation? Sin theta is equal to e to the power j theta minus e to the power minus j theta divided by 2j. Okay, using this equation we can directly write, or let me write here itself. We know that sin theta is equal to e to the power j theta minus e to the power minus j theta divided by 2j. This implies x of z is equal to summation n is equal to 0 to infinity e to the power j omega naught n minus e to the power minus j omega naught n multiplied by z power minus n divided by 2j. So this 2j is a constant which we can take outside the summation, 1 divided by 2j. Now writing the summation, n is equal to 0 to infinity e to the power j omega naught n z power minus n. I am separating out, okay, z minus n, z to the power minus n I am multiplying into the brackets, minus summation n is equal to 0 to infinity e to the power minus j omega naught n z power minus n. So this is what we will get. Okay, let us now rewrite the above equation in different form. Summation n is equal to 0 to infinity e to the power minus j omega naught j omega naught z inverse to the power n. Okay, similarly here n is equal to 0 to infinity e to the power minus j omega naught z inverse power n. Okay, now we can clearly see that this we can consider as some a, and this term we can consider as some term b. Correct? So it is b to the power n and a to the power n. Okay, so again we know that summation n is equal to 0 to infinity a to the power n is equal to 1 divided by 1 minus a when magnitude of a is less than 1. Okay, using this we can write the above equation. That is, this implies x of z can be given as x of z is equal to 1 divided by 1 minus e to the power j omega naught z inverse minus 1 divided by 1 minus e to the power minus j omega naught z inverse. Okay, now we have to simplify these two terms. So as to simplify, just first cross multiply 1 minus e to the power minus j omega naught z inverse minus 1 minus this forgot to write 1 by 2j, right? Sorry for that. 1 by 2j, this term. This is 1 minus e to the power minus j omega naught z inverse minus 1 minus of minus is plus e to the power minus omega naught sorry it is plus right? Omega naught z inverse. Okay, now this minus 1 plus 1 cancels out, and here denominator also we need to multiply, right? Denominator is 1 minus e to the power j omega naught z inverse multiplied by 1 minus e to the power minus j omega naught z inverse. So the answer is e to the power minus j omega naught and plus e to the power j omega naught. We can write it like this: e to the power j omega naught minus e to the power minus j omega naught 1 by 2j is there. So this resembles e to the power j theta minus e to the power minus j theta 1 by 2j. So sine of omega naught. This term will correspond to sine of omega naught. Now that we can write it later. So let us cross multiply the terms in the denominator. 1 into 1 is 1 minus 1 into e to the power minus j omega naught z inverse, then minus e to the power j omega naught z inverse multiplied by 1 is, again it is minus e to the power j omega naught z inverse. Finally minus e to the power j omega naught minus of minus e to the power j omega naught z inverse. So here we will get minus into minus plus, minus j omega naught and plus j omega naught will cancel out, that is 1. Z inverse into z inverse is z to the power minus 2. Okay, this is the term which we are going to get. So first let me consider this term. What is this? E to the power j theta minus e to the power minus j theta by 1 by 2j. This corresponds to sine of omega naught. Okay. Did I forget to write z inverse? Correct. Z inverse was there in this, right? So that is common. I can write it here. Okay. Or let me make it clear. Z inverse into would be better. So this term I have replaced as sine omega naught. What about this term? You can see here e to the power minus j omega naught minus e to the power minus j omega naught. If I write it here it as separately j omega naught minus e to the power j omega naught. So we know that cos theta is equal to e to the power j theta plus e to the power minus j theta by 2, or 2 into cos theta is e to the power j theta plus e to the power minus j theta. Correct? So if we have this one, we can write 2 cos theta. Similarly, if I take minus as common, I will get plus here. So I can write this as 2 into cos theta is here omega naught. 2 into cos omega naught. Okay. So with this, I can write 1 minus 2 into cos omega naught. Z inverse is there. Z inverse I will write here itself, 2 into Z inverse. So no need to worry about that. Plus Z inverse square. Plus Z inverse square. So this is our x of z. And this you need to remember, like it is not only ask for solving this problem. This using this problem, there are many other problems we need to solve. That's why you need to remember what is the z transform of sine omega naught n u of n. So this is what I have solved now. So instead of writing z inverse, here it is z square is taken as common. Okay, we can write in that way also. Z inverse is there. What I will do, I will take z to the power yes, z to the power minus 2. If I take out common, then I will have to multiply it by z into sine omega naught z square minus 2z cos omega naught plus 1. Okay, as here. And z to the power minus 2 and minus 2 will cancel out. Okay, here it is simplified at the end. In the notes, z inverse is converted into z. Okay, ROC should be greater than 1. For which problem?
Sir, it's for previous problem, sir.
Previous problem. Okay, let us see. This problem.
Yes, sir. Good.
Okay, it is not greater than 1, because you can see here when we solve at the very first instant. Okay, what we have is, when we apply this logic, what we are saying here, in this equation itself. Earlier ಇಲ್ಲಿವರೆಗೂ ಮಾಡಿರೋದ್ರಲ್ಲಿ z inverse ಅಂತ ಇರ್ತಾ ಇತ್ತು. So here it is z itself. Okay, so 1 divided by 1 minus a, provided that magnitude of a is lesser than 1. Similarly here 1 divided by 1 minus z, provided that magnitude of z is less than 1. So based on this, ROC is less than 1, and less than 1 because it is a left-sided sequence. Is that clear, Manjesh?
Yes, sir. Right.
That is because of the equation itself. Equation states that this is true. This is true only when magnitude of A is less than 1. That's why the ROC is less than 1. Okay. Any other doubt? So this problem I hope everyone has understood. You can represent in this term, both the terms are correct. That is, either you represent in z inverse form or you take out z to the power minus 2 as common, so you will get this form. Okay, both the forms are equally right. Okay, and ROC for this one is z greater than 1. Okay, z greater than 1. Why? Because if you remember the unit step function also, from there also you can conclude it is multiplied by u of n, right? That's why you can directly write ROC is greater than 1. Okay, unless it is mentioned multiplied by some specific constant. So ROC for this is z greater than 1 because we have multiplied the signal with a unit step function. It is a right-sided sequence, so we can write it. Okay. Now our next problem is x of n is equal to cos omega naught n u of n. So this I will give it as a homework. I will just explain it because it is similar to sine. Instead of using e to the power j theta minus e to the power minus j theta by 2j, we are going to use for cosine as e to the power j theta plus e to the power minus j theta divided by 2. Okay, so 2j is not there, 2 is there. So here it is what I can say, e to the power j omega naught n plus e to the power minus j omega naught n divided by 2. This is our x of n. X of n is equal to this along with multiplication of u of n. So if we substitute that, x of z will be summation n is equal to 0 to infinity. Remember this because of this multiplication. Minus infinity in the plus infinity iddittu 0 to infinity agutte. E to the power j omega naught n plus e to the power minus j omega naught n divided by 2 multiplied by z to the power minus n. Now after this what we get is n is equal to 0 to infinity. 1 by 2 we can take outside. E to the power j omega naught n z to the power minus n plus summation n is equal to 0 to infinity e to the power minus j omega naught n z power minus n. Okay, now this is again we need to simplify using say e to the power j omega naught z inverse power n plus e to the power minus j omega naught z inverse power n. Summation remains same. Okay, till now I have already told. Now this is our can consider as a to the power n, this as b to the power n. You can apply the rule summation n is equal to 0 to infinity a to the power n is equal to 1 divided by 1 minus a, provided magnitude of a is less than 1. Okay, so using this rule we can write this 1 by 2, simplification is left to e to the power j omega naught z inverse plus 1 divided by 1 minus e to the power minus j omega naught z inverse. Okay, so now after simplification you will get the answer as this one. You can go through these steps already which I have explained now. So till here we have completed. Now just z inverse is there, that you take on this side and you will get this equation. After that you just simplify and replace it with the equivalent cos and cos terms only, not sine. So this is the final answer with z greater than 1 again, because it is multiplied by u of n. Is that clear? Any doubt? So go through this. And unit ramp function we have already studied. This unit ramp function, multiplication by n, this we have already studied, and the answer for this is z divided by z minus 1 whole square. Okay, ROC is z greater than 1 because of this term here. Okay, z inverse is less than 1. This implies magnitude of z is greater than 1. So this one already we have studied. Go through the previous problems, you will get to know. Okay, it is repeated, that's why I am not going to solve this problem. Now let us move on to the next one. And yes, this one also we have done. It is left sided, but a to the power minus n is there. Instead of plus n, we have a to the power minus n. Okay, let us try to solve this one. Already solved, but we have encountered a to the power minus n for the first time. Till now, okay, this is the equation. A to the power minus n u minus n minus 1. This you already know. Okay, this already this z transform of this one is already calculated, but there minus of u minus n minus 1 was there. Here it is plus u. That means answer will be definitely having minus sign. Okay, remember. So this is the trick to remember the certain standard z transforms. Okay, so here this one is completed for cos omega naught n. Next, x of n is equal to e to the power minus n u of minus n minus 1. This is the problem. So x of z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. This is the standard equation. Now we can write it as n is equal to minus infinity to plus infinity a to the power minus n u of minus n minus 1. Okay, u of minus n minus 1 is there. So this is a standard unit step which will lie from n is equal to minus infinity to minus 1. Okay, now a to the power minus n, this z minus 1 forgot, so we can write z to the power minus n. So this one would be now n is equal to minus infinity to minus 1 a into z, sorry, a inverse z inverse power n. Okay, power n, or we can simply go by substituting n is equal to minus n. So let us do that, don't mess it up now. So directly we'll choose let m is equal to minus n. That means n is equal to minus infinity means m is equal to plus infinity, n is equal to minus 1 means m is equal to plus 1. So using this we can write x of z is equal to summation n is equal to infinity to 1 a to the power m z to the power m. So this we can write as n is equal, sorry, m is equal to 1 to infinity a to the power m z power m. Okay, now this can be simply written as summation m is equal to 0 to infinity a to the power m z to the power m minus 1, because when I substitute m is equal to 0, a to the power 0 is 1, z to the power 0 is also 1, so 1 minus 1 will be 0. Again we left with the terms m is equal to 1 to infinity, so we can simplify this one, that's why we can represent in the given form. Okay, so this will be our summation minus 1. So what is this summation means to us? Summation n is equal to 0 to infinity a to the power n is equal to 1 divided by 1 minus a, provided magnitude of a less than 1. Okay, so we can write it as 1 divided by 1 minus a into z minus 1, and az magnitude should be less than 1. That means z magnitude is less than 1 by a, or z magnitude is greater than a. Okay, greater than a, is that correct? For instance, yes, no, it is 1 by a. That's why. In the reverse order also it will be like if you take a here, z will be 1 by z. So this is correct. Magnitude of z is less than 1 by a. If I substitute a is equal to 2, z will be less than 1 by 2. Okay. So left sided sequence lesser than the highest pole. So now simplify it. 1 minus az divided by 1 minus a into z. So this minus and minus will cancel out. Minus az divided by 1 minus a into z is the answer. Okay, so the same thing has been written in the other form here. You can take a as common, means minus that divided by 1 by a minus z. So this minus will be there. A and a will cancel out. Again I can write. So plus ಬರಬೇಕು ಅಂದ್ರೆ ರಿವರ್ಸ್ ಮಾಡಬೇಕು ಸೈನ್ ಅಷ್ಟೇ. Z minus 1 by a. What is the mistake which I have done? Z minus 1 by yes, it is correct. Here we did not put this minus into minus is plus. Okay, so it is plus z divided by 1 by a minus z. So if I take this as minus z, if we consider minus as common, then it would be z minus 1 by a, and this minus we can place here, minus z divided by z minus 1 by a. Okay, so this is the answer for the sequence. Let me write here. X of n is equal to a to the power minus n u of minus n minus 1. For this sequence, Z transform is minus z, z minus 1 by a, and ROC is magnitude of z is less than 1 by a. Okay, so this completes the problem. Any doubt till now? And this problem number 9 in the slide page 21 is homework, because already we have solved this kind of problems in the very first class. Okay, so go through it. We'll discuss this because ROC concepts again we are going to discuss based on this. That's why go through this. Now I want to solve another important problem. This one. So here x of n is equal to, it It is a finite sequence, not an infinite sequence. X of n is equal to a power n from 0 to n minus 1. So summation limits will be n is equal to 0 to n minus 1 a power n. Already we know the answer for this, but a is greater than 0. A is greater than 0, he has given, but to what extent is not given. That's why we need to choose B, that is A not equal to 1 and A equal to 1. Those conditions, based on that we have to write the equation. Okay. In this problem, we are assuming that A is greater than 0, but A is not equal to 1. So based on this assumption, we are going to solve this problem. Okay, it is simple, whatever we have already calculated based on that only, but the summation limits are this, and the equation which we have given in the very first page, let me show you that. You can see here, this one n is equal to 0 to n minus 1 a to the power n is 1 minus a to the power capital N divided by 1 minus a, provided a not equal to 1. If a equal to 1, then the result will be n. Okay, same result we are directly using in this equation, or using in this problem. This problem tomorrow I will solve, that is plot the poles and zeros. Plotting of that I will solve, but you need to complete the problem till here. Okay, so make sure that you are writing the notes, otherwise it will be very difficult once the second module is completed and you will be having the third module for your IA. Okay, there is a lot of time which elapses.